Now we're going to look at some relationships between sine, cosine, and tangent. Now these are properties that we've seen before. Pythagorean theorem and the angles in a triangle add up to 180. So Pythagorean theorem, we know that a squared plus b squared equals c squared. And we know that the angles in the triangle add up to 180 degrees. But because we're working with 90-degree angles, let's call this alpha and beta, we know that 180 degrees minus 90 is going to give us 90. So that these two angles here, 90 is going to equal alpha plus your beta. Or you can write it as 90 minus alpha equals your beta. So we're going to look at sine and cosine. For angle alpha, we have our hypotenuse, which is going to be our c. For alpha, a is going to be our opposite. And for alpha, b is going to be your adjacent. So if I was to look at sine of alpha, sine is opposite of hypotenuse again, if you need to remember. SOHCAHTOA. Make sure you know how to spell it. So sine is opposite of hypotenuse. My opposite in this case is a over c. Side a over c. Now if I was to look at cosine of alpha, that equals adjacent over hypotenuse. That's going to be b over c. But what if I was to look at it in terms of angle beta? The opposite side is over here now. So cosine of beta, sine we'll start with. Sine of beta, my opposite is going to be b over c. And my cosine of beta, adjacent over hypotenuse, is going to be a over c. So we can actually see that these two things are the same, and that these two things are the same. They have the same ratios. So because they have the same ratios, we can actually say that sine of one acute angle equals the cosine of the other angle. Now, using this fact as well, so this is one important identity to identify. Using this fact as well, we can also use this fact here. If beta is equal to 90 minus alpha, we can also say that sine of alpha is equal to, in this case here, cosine, and we replace beta with 90 minus alpha. So now we have two properties. We've got the first one here and the second one here. Those are two useful properties that we're going to use in this section for the homework. The next property, we're going to look at another triangle again, and we're going to look at how Pythagorean theorem works in conjunction with sine, cosine, and tangent. So what we're going to do is find, with this angle theta, we're going to find sine of this angle and cosine of this angle. So sine of A, again if you need to see it, SOHCAHTOA. Sine is opposite of our hypotenuse. Based on A, if we label our theta, we have an opposite over here, hypotenuse here, and adjacent here. So sine of A is going to be our opposite of our hypotenuse, A over C. Our cosine of A is going to be our adjacent over our hypotenuse. Now, if we look at this, everything in terms of A, B, and C. So let's isolate for A and let's isolate for B. So we take this one here and we isolate for A, we times both sides by C. So you get C sine A is going to equal little a. And here, if we isolate for B, we times both sides by C, we get C cos A is equal to B. So we want to write it A squared. That's A So if I square both sides of the equation, that'll get me to where I need to be. So we're going to square this whole thing, and we're going to square a. Now, when you have two things that are being multiplied, c is being multiplied to sine of a, both things get squared. So you're going to get c squared and then sine of a squared. Now how we write this algebraically is like this, because sine is being squared, not the angle being squared. So now I have that. On this one here, same idea, we're going to square both of these, both sides. When I square this, both terms get squared, so I get c squared, and again cos squared of a, because the angle is not being squared, it's the whole function of cosine that's being squared. And we get this. So now if I take my a squared plus b squared equals c squared, I replace a squared with this whole piece. C squared sine squared of a plus, and wherever I see a b squared, I'm going to replace it with this right here. C squared cos squared of a equals c squared. Now, everything's got a c squared in it. So why don't I factor out c squared by dividing every single term by c squared? If I divide everything through by c squared divided by c squared becomes 1. When I divide this by c squared, I'm left with just cos squared of the angle. And when I divide this by c squared, I get sine squared. This is another useful property that you're going to use in this homework assignment. Now, what we've done so far is I've shown these three things. Sine of a is equal to cos of b, where a and b are your two acute angles. We've also shown that sine of a is equal to cos of 90 minus a, because we know that the two acute angles have to add up to 90 degrees, and 90 minus that angle will give me angle b. And I've also shown this identity here, which is referred to as the Pythagorean identity. So what I would like you to do, and you can read through your book, but I would like you to look at how these identities fall from these identities.